and to build a model, and then I'm going to test it with the test data. Now, like it says, it is a tree. So what is so it has a node. A node can branch off into multiple leaves, okay, and it itself can have multiple attributes. Now, what are we branching off of? We are branching off of attributes. And whenever I reach a leaf node in the tree, or the tree doesn't further branch off, that is considered as a class. So I'll repeat, in a decision tree, it's a tree structure and not a graph structure. It's a tree structure, and we are branching off each node based on an attribute. And whenever a leaf node is reached, we can either represent the leaf node as a square, just so to say that we have reached the leaf node, and that would be the class. Now, let us take the infamous example which you have in your in your class, which is, hopefully this text file opens. Okay, the sunny heart, the tennis playing thing. Now, except the last column in here, which is a no, no, yes, yes and no's are the classes, the class or the decision class, and rest of it are considered as attributes. Okay. Now, so there, what are the types of attributes where we can have? Okay, so I can have a binary attribute, which means an attribute which contains only two values. Okay, and then I can have a multi-valued attribute, which means more than two values, yet more than two, yet finite values. When I say multi-valued, it's not some random, but probably I'll have more three or four or five or 10 or 20 values, but yet I can have finite set of values. Okay, and then I can have continuous attributes. For example, um, you know, let us say if I have an attribute which says salary, right? Like I said, each and every rupee matters. So it's not discrete, but it is continuous. Okay, so which means it can last from anywhere to any number of decimal points to, you know, so that's one of the attribute you can have. Okay, now I want to hand to one of the um, one of the things which we have over there, and I'll also use Microsoft Excel to let you understand how to, you know do a particular problem. So, and then we'll go for Python and stuff like that. So let's take it step by step. So the first thing, now let's say I in this same text file, let's take the same text file, right? Other than the last column, which is yeses and nos, which is, the class for me, I have four more attributes, right? And I have some n number of rows in here. Let's use all of it as a training data for now, but I will tell you how to split it between a training data and test data later, in the latter point of time when I'll come back with a huge set, and then how to split between training data and set that as, test data. We'll take a look at it later. But let's say I want to just use this particular example, and try to build a decision tree, or I try to build, or at least build one level of decision tree. Okay, so let me try to see how to make it more interesting or without boring you people, but I'll at least try to build one level of it. So there are four attributes. Okay, there are four attributes, and which one to start with first? I I don't know which one to start with first, right? So I can start with my first column, I can start with the second column, or the third column, or the fourth column. So, and in order to make that decision, we have various mathematical formulas for that, which we call it as an impurity measure. Okay, you will see an algorithm which is ID3. In that we use a kind of an impurity measure. But what are the types of impurity measure which we use? One, Gini index is one of the impurity measure we use. Another impurity measure we use is entropy or information gain. Okay, entropy or information gain. Now, this concept of entropy and information gain is picked up from, if you have studied digital signal processing or things like that, Shannon's, you know, entropy, that is where this concept of entropy has been picked from. Another impurity measure is the classification error. And chi-squared is one more. Chi-squared is one more. So these are all impurity measures. Now, the keyword in all of these is impurity. That means when I am choosing an attribute, I want as much less impurity as possible. I'm sorry. So let me take a step back for entropy and information gain. Information gain is, let me scratch it for a minute. I'll just keep entropy in the pipeline. So entropy is an impurity measure, but information gain is based off of entropy. So I'll just keep the concept of information gain aside for some time. So there, if I want to measure the classification impurity based on a attribute, I use these impurity measures. Okay, so let me give you how to calculate a Gini index. Okay, if I need to calculate Gini index, 1 minus sigma I equal to 0 to c minus 1, where c belongs to a class, probability of I given t whole square. Talking about probability of I given t, I'll just show you with a small example. And please correct me if I do some counting mistakes and things like that. Now, let us take one thing, first column here. Sunny, overcast, and rain. This is clearly a multi-way attribute, right? Now, I have sunny, overcast, and rain. Clearly a multi-way attribute. And then I have two classes, yes and no. Okay. Now, how many of them have sunny and no? Let's try to fill this particular table. Sunny and no, 1, 2, 3, and that's it. So sunny and no is 3. Similar way, sunny and yes is how many? 1, 2, that's it. Do I have another sunny and yes? No, 2. Similarly, overcast and yes and overcast and no. So overcast and yes is 1, 2, 3, 4, and overcast and no, I believe none. Then I have rain and yes. So 1, 2, 3, and rain and no is 1 and 2. Okay, this is awesome. So let's try to calculate the Gini index for this thing, and then I'll switch to Excel and I'll show you how to import that particular CSV and do some calculations handmade, and then we'll write the program for the same sometimes in the next class. Now, let's calculate the total. This is 5, 4, and 5. So if I need to calculate the Gini index of Sunny is 1 minus 2 by 5 whole square minus 3 by 5 whole square. Okay. This will be the Gini index of Sunny, which is 1 minus. I could be wrong in I could be wrong in calculating. I'm not using my calculator yet, but or I could have miscalculated when I'm doing something here. Apologize for that, but I'm just basing off of whatever I'm doing here. So which is 4 by 25 minus 9 by 25. Hopefully I'm okay with mathematics. So 1 minus 25, 4 plus 9, 13. So 25 minus 13 by 25 is, what is that? 12. Oh, give me a minute. Yes, 12. Sorry, 12 by 25, which accounts for what? Something less than 0.5, 0.48-ish. I'm using my mobile to check the exact value. About 0.48-ish. Yes. So Gini index of being sunny is 0.48. And, let's say this Gini index is merely, let me see, 1 minus 1. 1 square is 1. I'm sorry, 1 minus 1 square is 0. And this is same as 0.48. So I calculated the Gini index for each value in a particular attribute. Now, I want to see overall impurity of this particular attribute. Then I take the weighted average. I take the weighted average. What is the weighted average? Is so the total of this is 14. So 5 by 14 times 0.48 plus 4 by 14 times 0 plus 5 by 14 times 0.48. So this accounts for 0. And then I have 2 times 5 by 14 times 0.48, or 5 by 7 into 0.48, which would be, again, I'm using my calculator to do it, is 5 divided by 7 times 0.48 is around 0.342. 343. Fine. 3428 is 343. So this is my Gini index of the attribute itself. Okay. Now, which one to choose? I have 4 of it, right? If I want to see which one to choose, then I would probably want to calculate for all of these. In having computers, it's pretty easy for us to do, or having writing a program is pretty easy for us to do, not to hand make it. But I just want you to get a glimpse of how to make that particular calculation. Now I'm going to open up an Excel file right now. Give me. Okay, I'm going to open up an Excel file. Hopefully my computer allows me to do that. Yes, it does. And I want to show how you do something using Excel, and then we'll sometimes this week or sometimes next week we'll switch to Python. And I'm just going to close it. Okay. Now, what I'm going to do, okay, so before I start with the Excel file, I want to know if you're able to see my Excel file and any doubts on how to hand calculate something. I'll also tell you about log entropy, but in some time, and information gain as well. But I just want to do a quick pulse check on if you have any doubts. Okay, so let's go ahead. And so I tried to load the CSV file to the Excel. Okay, so it beautifully loaded it for me. I have some amount of columns and rows in here. Okay, awesome. I'm just going to close all the other stuff. I don't care. Okay, so now what I'm going to do is let's calculate. I'm going to just start from here. I have 2 classes, yes and no. How do I calculate? So let me take the first column, which is I have sunny, overcast, and rain. Right? So here I can probably count it and write it, but I'm going to use some capabilities of Excel itself to see, hey, count if this thing from among these columns, if it is equal to sunny and that equal to yes. Oh, sorry. It should be these set of columns, comma, that. And I'm going to make a slight modification here. I'm going to append dollar on each of it. Just so you know, if I am able to drag drop something, I should be able to do it. So sunny with a yes is 2, and I'm just going to drag drop here. I'm going to drag, and Excel is going to take care for me. Okay. That means this number is overcast with a yes and a rain with a yes. Now, let's do the same thing here. Countifs. This particular column I'm selecting, comma, with sunny, comma, and the column being comma and a no. And over here, I'm just going to say I'm just gonna pin $1 just so you know it doesn't kick off, my when I drag something. Okay, so looks like my calculation was right. Okay, then now what I'm going to do is I'm going to calculate the sum of this plus this, right? Okay, awesome. That got the sum. Now I'm going to calculate the Gini index, and I'm also going to introduce you to entropy. The formula for entropy would be similar to Gini index. For Gini index, I said it is 1 minus that part there. Okay. Now for entropy, it will be minus sigma I going from 0 to all the classes. Okay. Um, sorry, P of I, probability of I given T, log 2 base 2 of probability of I given T. As again, yes, it is set a probability, but when you really think about it, what I am doing is actually in reality a probability, and given T means given a particular value in the attribute, right? Oops. Sorry. Okay. We say that it is probability of I given T. I mean, in reality, yes, it is a probability if you think about it, right? Because after all, what is a probability? Something happening overall by a sample space, right? So what I am doing is indeed probability. If you go back to your, I don't know when you learn probability, third semester maybe, you will see that it is indeed a probability in what I'm doing. But nevertheless, let's keep the probability aside and go with pure math. Now here, what I'm going to do, I'm calculating the Gini index here. The Gini index is, um, 1 minus. Okay, since I have only 2 classes, it's pretty easy for me. What I'm going to do is that divided by bat squared minus that one, which is my other class, and that one square, right? About the same whatever we calculated, right? Now let's go to entropy. Now entropy is a bit challenging, I should say. So I'm going to keep typing. Let's see if I see an error, then I'll probably fix it at that point. Minus that one divided by the sum star log of, again, that one divided by the sum, comma, to the base 2. It's not any base, but it's base 2. Again, it's a summation of among all the classes. If you see, the summation goes from 0 to C minus 1. That means it's all the classes involved. So I have 2 classes here, so I have to repeat it twice. Okay, but when you're writing a program, make sure you also consider multi-classes and not just 2 classes. Okay, that one divided by the sum star log of, again, that one divided by the sum, comma, 2. Okay. Okay. So this one gave me a number error. Okay. So because I believe the number, it's exceeding something. So what I'm going to do in this base is I'm going to say if there should be an if error. Yes. If error, that means if you see some number error or something, or it's giving a number error because I think it's exceeding some calculation limit. So if the error is there, then just return 0. So that solved my problem. Now I'll come to the weighted um, Gini index and things like that, and how to proceed further from there in some time. But let me just do the same thing for column 2, column 3, and column 4. So I have 3 things in column 2: hot, mild, and cool. So in this first box of calculation, any clarifications before I proceed with the next box of calculation? Any clarifications at all? Okay, I'm just going to proceed further to do the same thing. Here, countifs of, I'm going to take this column, comma, that one, comma, this column, comma, that one. But I'm going to, sorry, that one, but I'm going to put a dollar here so that in order to survive, when I drag something. So hots and S's are 2, mild and S is 4, cool and S is 3. And I'm going to say do the same thing for countifs. Hot, comma, that, comma, that one, comma, no. And as again, I'm going to prepend it with a dollar. If I drag it, I'm just going to get all the count. Now, what I'm going to do is I'm just going to drag it because it's the same formula, except it will have some unwanted value over here. So these are the sums of, a particular attribute. Now, again, I'm going to calculate the Gini index here. I'm going to divide by 0 here. Okay, so those are the values for Gini index. Again, it's the same thing, 1 minus sigma I running from 0 to all the classes, probability square is what I'm taking here. And so as the entropy, I am, so this doesn't make sense to me. So I'm just going to, so these are the entropies for each of the attribute. So similarly, I am going to choose, or I'm going to do it for column 3, which have just 2 attributes, good for us, normal and high. And I'm going to do like the same countifs. That one, comma, normal, comma, this one, comma, yes. I'm going to prepend it with a dollar again. Okay, normal and S are 6, high and S are 3. Similarly, I'm going to do a countifs again with that, comma, normal, comma, this one, comma, no. Okay, and it's going to give the relevant formulas. And all I'm going to do is drag more just to, backfill in all of these. We'll also calculate the Gini index, or the computer calculates it for us based on whatever I have inputted before. And these are the entropies for that. Okay, now the last column, I have 2 things, strong and weak. Okay, so I'm going to do for the last time the same thing. comma that, comma that one, comma, just going to type in here. Okay, and that one with strong, and that one with yes or no. So I'm just going to type in anyways. So I'm just going to drag this again just to get the sums and the Gini index of both and the entropy of both. Now, just by looking at this, what we have got until now, I have taken 4 attributes for whatever the 4 attributes I have, and for each value, I have calculated the the Gini index of individual values. Now, all I need is the weighted average of it. Okay, just to figure out what is the just to figure out what is the what attribute I got to select. So I'm just going to say weighted average Gini index for Gini index. Okay. Sorry. Okay. Now, if you really look at it, I have the formula here for the weighted average. It's the sum product of the Gini index of the individual value times the individual attribute divided by the sum of everything. So I'm just going to use the same formula here, sum product of this thing, comma, the Gini index divided by sum of this thing. Now, that's the weighted average Gini index for the column 1 attribute. Similar way, I'm going to do, rather than that, I can just drag and drop this. It will, I don't know if it works. Let me not take risk. Sum product of this thing, comma, that thing, divided by sum of this thing. Okay, now that's the weighted average Gini index for the second column. For the third one, as again, I'm going to do sum product of these things, comma, these things, divided by sum of that thing. Now I got the Gini index of this attribute, and finally I'm going to do the one for divided by sum of. Now, if you clearly look what attribute to choose from the weighted, again, these things is, like I said, it's an impurity measure, right? That means I want to choose something with as much less impurity as possible, which is why I'll be choosing the first attribute based on the Gini index. I mean, but just by looking at the values, you should be able to tell that, the first one's Gini index is lesser. Okay. Now, the same thing can be done for entropy, and, information gain is, I can explain you about information gain in some time. The entropy of a parent minus the entropy of the kid, the children, is where it gives you the information gain. So entropy is kind of, inversely proportional to information gain. That means entropy is an impurity measure, as opposed to information gain is I want the more information. I want to choose the attribute with more, you know, gain in information. Now, um, I think I can just spend a couple of minutes doing the same thing for entropy as well. Okay, some product of that one, comma, the entropy divided by sum of that. Okay. Similarly, some product of entropy times the sum divided by sum of, all the attributes. Awesome. Then I'm going to just do the same thing. Some product of that divided by sum of that, and similarly some product of entropy, comma, the sum of those divided by sum of those. Okay. Now, if I look at this, I think the entropy is also giving me the same result, saying that, hey, you got to choose the first one in order to make sure, you choose, you got to go with the first one with the least entropy, to choose, that's the first attribute with, that will be my root node. Now, rest of the ones I won't be doing it, but I'll just, this is like an iterative process until you get all the leaf nodes. Now I'm just going to take a couple of examples here and how Hunt's algorithm, or ID3 started off with. Okay. Now let's take a look at overcast. Okay. So I'm saying what I just did is I just took the filter here and said overcast. Okay. Now forget the numbers change here. Don't worry about it. Now, if you look at the overcast, all of the class items in here belongs to the same class. Hey, so do I really have to calculate the Gini index or entropy for that one? I don't believe so. So that is where, the writers of algorithms like, ID3 or Hunt's algorithm, they found out that, the first step, hey, do we have an attribute where a particular value boils down to one particular class? If you see any of those algorithms, that's what we do. That's an optimization. Now, from that, we kind of figured it out that, hey, that is the first thing we look at. And then let's take, so one other attribute, which is rain. Okay. And even if you see, if I blindly by looking at it, if I if I split it by column 4, all the weeks have, yes, if it's week, so I can split it by column 4, which says weak, yes, and strong, and no. I don't have to look at other columns. So if I split the tree, or if I split the children under rain, I think my Gini index of column 4 would be lower. So that will be the attribute I'll be selecting. Okay. So this is how you basically build the, decision tree. Okay. So this is decision tree, and using the training data, this is the algorithm it follows. First, it will check, hey, do I have an attribute where, a value from it always boils down to a given class? If yes, then that's the attribute I'm going to choose first. If not, then I'm going to go ahead and choose any of the impurity models. In ID3, we choose entropy, or we also calculate the information gain, and we choose an attribute with more information gain. Okay, and then we split it based on that particular attribute. Okay, and we do it again, like I said, we do it iteratively until we, you know, go into the leaf node. Any clarifications until now? Any from what I explained? Do you want me to take? I have one more example ready with me. If you if you want to, if you want me to do it, but basically this is the way you do it. Okay, so going back to our thing, if you look at this, right? I mean, yes, we have limited attributes. Our tree size would be limited, right? And it's more predictive. You know, the the when you build a model, it's done. You use the model just to predict all the test set and how it is doing and all of those, and done. Okay, so that is the one. Decision trees are, like I said, relatively easy when it comes to a smaller data set and smaller size of tree. But building a tree is kind of, with 2 power, if you consider the depth of the tree as 3, 4, 5, whatever, if you have huge attributes, then it becomes a big tree with a lot of data structure to maintain. Okay, then another problem with decision tree is this. So let's say I have a tree. Okay, and let's say I have a big decision tree in here. It could so happen that there could be repetitions. Okay, it could so happen that there could be repetitions. So that's a huge amount of maintenance problem. Okay, a subtree could be replicated. Okay, and so these are some of the advantages and disadvantages of you know um, the decision tree. In the next class, I'll give some time for you to go back to your textbooks and read through this. Next class, I'll talk about what is underfitting and overfitting. I mean, the concepts of underfitting and overfitting is universally used with all the classification techniques, but I think this specific decision tree model, is a very good example to study those underfitting and overfitting. Okay. So that's all for today. Any clarifications at all?
Students, any doubts?
I would strongly suggest you basically do the same thing. Take the same data set, open up an Excel, try to do it for yourself. You know, on top of it, I can give you one other data set where you can one other small data set where you can do the same exercise, whatever I showed.
Okay, sir. Thank you so much, sir. Thank you for your time.
Thank you, ma'am. So next class we'll take a look at what is overfitting, underfitting.
Yes,
Uh,
sir. One doubt, sir. Is it on Friday or Saturday? I have not scheduled yet to the students because you said either Friday or Saturday,
yes.
or let us sit on Monday, next Monday itself. How was it, sir?
Let me take a look at my calendar and get back to you, ma'am.
Yes, sir. Please text me, sir.
Sure, ma'am.
I'll inform it to the students in the group.
Sure.
Okay. Thank you so much, sir. Thanks a lot.
Thank you. Thank you. Thank
Yes.
you.
Yes, students, you can leave. Thank you all.
Thank you, and have a good rest of the day.
Sankadeep, Vaishnavi, Sumanjali, you can leave. Sankadeep, are you listening to me? Vaishnavi A, Vaishnavi Jaiswal, Sumanjali. Okay, I'm closing the session.